5-2C. This is a pretty short lesson because I want to spend most of the time reviewing for your quiz on Friday. So 5-2C, we're going to talk about the antiderivative. Some of you already are antiderivatives. Is that one word, antiderivative, or is it like a hyphen? I don't even know. It's one word. It's one word. All right, here's what it is. So basically, what you're going to have is if f, they call it capital F, prime of x, f prime of x is equal to the derivative of f of x. Okay? Then we can find f of x. All right, so if f prime of x is our derivative, then we can find f of x from that derivative. So I'm just going to go ahead and jump right in, teach you how to do it. The thing is that we're going to always need to add a constant. Okay? Add a constant. So let me show you what I mean by that. Okay? So let's say that I have a function. F of x equals x cubed plus 3x plus 4, right? And I tell you to find the derivative of that function. You guys all by now can find the derivative of that. It's a polynomial, super easy. Use the power rule. You bring down the 3 to multiply. You subtract 1 off. You go to the next one, bring down the 1, subtract 1 off, and the derivative of 4 is 0. Today, we're going to go backwards. We're going to start with f prime of x and find out what the function was. Now, we can do that except for the constant part. We can't really find the constant, so we just end up writing plus c, okay? Unless it gives us an actual point on the graph. So let me show you a couple of them, how to do it. Here we go. Number 1, find the antiderivative. They get a little tricky. Derivative. An antiderivative. All right, so here we go. Let's say that f prime of x, they use capital F, I just use regular F, whatever. F prime of x is equal to 2x on the interval from negative infinity to infinity. We don't really need that either. We need to find f of x. All right, so here we go. This is a polynomial. We're going to do the opposite of power rule. Power rule was to multiply and then subtract, right? We're going to add and then divide. We're going to do the opposite and the opposite order too. Okay? So for power rule, we multiply that number down and then subtract 1 off, and that's how we got it. Here we're going to add one number to the exponent and then divide by that number. So this is a 1, and so if you add 1 to that, you get 2, okay? So we get 2x squared, and then we're going to divide by that exponent, and so our answer is x squared, and then you have to do plus c, plus some constant. Because this could have been, f of x could have been x squared plus 3. And that would give me the derivative of 2x, right? F of x could have been, bless you, x squared minus 10. And that would have given me the derivative of 2x also. Yeah?
So you're saying we learned to take derivatives just to undo what we did?
Yes.
All right.
Yes. You need to have a really good understanding of derivatives because then you do, the opposite of derivatives. But then there's going to be an actual thing, the reason why. It's going to be amazing. But we can't teach you that yet. Okay. All right. And then look, if you look at your answer and you take the derivative, you already know how to do this? Oh, good. If you look at your answer and you take the derivative of it, you get 2x plus 0 is 2x. And that's what that is right there. Okay? You can always check your answer by taking the derivative to see if it's actual going to work. All right, let's do another one. Number 2. You want a little harder one?
Yeah.
Okay, sounds great. Let's say that f prime of x equals 2x cubed plus 3x plus 5. And we want to find f of x. So we're given the derivative, and we got to go back in time to find out, like someone took the derivative of a function and it turned out to be this. Let's find out what that function was. Okay, you want to try it? You want me to walk you through this one? Yeah, some of you got it, some of you don't. Okay, first thing you want to do, so this is the anti-power rule. So we're going to add 1 to 3 and then divide by that number. Okay, so I get 2x to the 4th divided by 4. I get x to the 4th over 2. Drugs are ready. All right, does that make sense to you? And then take the derivative of this. If I brought the 4 down, it would go 4 over 2, which is 2, and I would subtract 1 off and get 3. Okay, so you can check your answer. All right, the next one, and you can write 1/2 x to the 4th if you don't like it written like this. The next one is I would add 1 to 1, so I get 2, and I would get 3x squared over 2.
It's always divided by 2, right?
No, I divided by 4 on this one. It's always divided by whatever your exponent is. And then this one, what's 5? Well, it's kind of like if you put an x to the 0 there, right? So you would add 1 to that, and you know the derivative of 5x is going to give you 5. So some of them you just don't have to do that whole process of adding 1 and dividing by that. And then do not forget plus a constant on the end. Okay? And that would be the antiderivative. There it is. Now, sometimes they're going to give you a point that you actually then will have to find the exact function that it was, okay? So, for example, let's go back to that first one where f prime of x is 2x, and then we found that f of x is x squared plus c. But then they might also say that suppose that the point 46 is on f of x. Suppose that the point 46 is on f of x. So now what we can do is we can find the exact function that's going to work. Instead of plus c, there's an infinite amount of functions. But when they give us a specific point, we can find the one that does fit. So what do you think we're going to do? Yeah, we're going to plug it in. Exactly. So you're going to take 6, plug it in for f of x, take 4 and plug that in for x, and solve for c. We'll find out what exactly that constant is. So that constant would be -10. Good. And so my function would be f of x equals x squared minus 10. And if I take the derivative of that, it still equals 2x. It's just I know what the constant is that time. If they don't give you a point, you're going to write plus c every single time. All right, let's do a different one now. How about this one? F prime of x is equal to cosine of x. F prime of x is equal to cosine of x. Okay, power rule's not going to work here. You have to know derivatives, right? So f of x, what function gives you a derivative of cosine x? Sine x. Plus c. That's it, right? Derivative of sine is cosine. Yeah, you're working backwards. It's a little harder. Stephen, is it hard? You're not listening. All right, number 5. You don't need to. How about this one? This one always used to get me. F prime of x is equal to 1 over x. Shh, don't say anything. Don't pay attention. Ooh. All right. Think about what's going to give you the derivative of 1 over x. Do you remember that? Natural log of x plus c. Oh, right? Remember the derivative natural log of x is 1 over x? True. I know. Here's the thing. You know what I do? I would change this, like when I would do these and I couldn't figure it out, I would change this to x to the -1, right? Because that's the same thing. And I would try to do the power rule by adding 1, and I would get x to the 0. So I know that's not going to work. So then I got to think something else has to work, and then I go, oh, duh, natural log. Okay? So that's another way to try it. Because something like this, number 6, f prime of x is equal to 1 over x squared is not going to be the natural log. Okay? This one's different. So they are. That's what makes them kind of difficult, yeah. So for this one, I would change this to x to the -2. And then I would do power rule, anti-power rule. Do you remember what anti-power rule is? You add 1, and then you're going to divide by whatever that exponent is. Add 1, divide by the exponent. So then f of x would be, if I were to add 1, I would get x to the -1, and then divide by -1. And so then my answer would be -1 over x. Okay, and if you took the derivative of this, it will equal that, 1 over x squared. Plus c. Oh, no one corrected me. I forget it all the time.
-1.
So encouraging that you forget it.
Do I get to go home? No? Dang it. All right, let's do 2 more, and then I'll hand out the review worksheet. Number 7. What do you mean, what? All right, how about, ooh, you want a hard one? Yeah, you do. F prime of x is equal to 1 over 5 x to the 4/5. It's really not that bad. It looks bad. It's not too bad. You want to try this one?
Sure.
Okay. Yeah. All right, so for me, I would change this to be 1/5 x to the -4/5. That's what those are exactly the same thing, and that helps a lot. And so I would add 1 to this, and adding 1 is adding 5/5. And then you would take that, add 1 to it, and you get 1/5. And then you want to divide by 1/5. Now, nobody likes to divide by fractions. So let's multiply by 5 instead. Perfect. And so we would get that, f of x. F of x would equal x to the 1/5 plus c. Who got that? Yeah? Ooh, lots of you. Good. Okay. All right. Now, let's talk about what's going to be on the quiz. Okay? So the quiz, I'm going to have a worksheet that's going to come out to you. It's going to help you prepare for the quiz. We're going to start with something on the quiz, the mean value theorem. I will give you this formula where you're trying to find some point C where the slope is going to equal the slope of the secant line. Okay? So there it is. This is on a closed interval from A to B. And you're trying to find the same point that has the slope as the secant line. All right? Do you remember that? Yeah? So like, for example, if you had something like this, and we had, ew, gross. We had the secant line that goes through A, x is A and x is B. We would find probably 2 on this one, where the slope would be exactly the same. Okay? And this formula will be given to you, so you don't need to memorize that. Then you're also going to have to find extreme values. That was from lesson 5.1, but you need it in order to do lesson 5.2 because you're going to do increasing and decreasing intervals of your function. Okay? And don't forget, you test f prime of x, and if it's greater than 0, then your function is increasing. And if f prime of x is less than 0, your function is decreasing on that interval. And then the last part of the quiz will be antiderivatives. They're going to be on there. Okay? All right, let me hand out the worksheet. The worksheet doesn't include the mean value theorem. I forgot, so we can try one of those too.